So in this video we'll be studying definite integrals, okay, the one which you originally studied when we found out areas under the curve. So consider a function, okay, capital F of x, differentiate it and you get small f of x, okay. So you can say that integral f of x dx is capital F of x plus c. This is the derivative, this is the antiderivative, okay, and the integral of your derivative gives you a family of all antiderivatives. That's why we put a constant, because if you differentiate this function with a constant, you will get the same f of x. Alright, now there's a theorem in calculus, the fundamental theorem of calculus, that will relate the definite integral and the antiderivative, okay. It says that you integrate f of x dx, okay, with the limits a to b. So integral f of fx dx from a to b, this is the antiderivative evaluated at b, okay, the upper limit minus f of a, your antiderivative evaluated at lower limit. So this is a fundamental theorem of calculus, okay. Now let me just give you a quick example. So if I ask you to integrate between the limits 1 to 2 x dx, okay, so integration x to the power of n dx is x to the n plus 1 divided by n plus 1. In this case the n is equal to 1, so we get x square by 2, and we'll integrate it from the limits 1 to 2, okay. We can write it in this form. This means we put 2, okay, x square by 2 evaluated at 2, so this is 2 square by 2, okay, minus this thing, this is the antiderivative evaluated at 1, so this is 1 by 2, okay. So this is 2, so 2 minus 1 by 2, this is 1 by 2. Now let us see another example of this. So we need to evaluate this integral sine cube x dx from 0 to pi. Now I'll be using a trigonometric identity, okay. Sine 3x is equal to 3 sine x, 3 sine x minus 4 sine cube x, okay. So this gives that 4 sine cube x is 3 sine x minus 3x, okay. So 4 goes to the denominator, we get sine cube x as 3 sine x minus sine 3x, okay, this is sine 3x divided by 4. And this is how you usually integrate trigonometric functions. You use your trigonometric identities and then put given your integral, because it's much more convenient. We'll see how. So 1 by 4 goes out of the integral, okay. You're left with 0 to pi 3 sine x minus sine 3x dx, okay. And now using a property of standard results for integrals, we split this out, so we get 3 by 4 0 to pi sine x dx, okay, minus 1 by 4 integral 0 to pi sine 3x dx, okay. This is cos x, alright, or minus cos x, and we need to evaluate this one. So you can use u substitution here, alright. So you can define u as 3x, so from this we get du by dx as 3, dx as 1 by 3 du, okay. So you can replace dx here with 1 by 3 du and you get minus 1 by 4 times 1 by 3 integral sine u du. Now here's the interesting part where we change our limits. So u is equal to 3x, okay, and x goes from 0 to pi. So what will be the limits imposed on u? U will be from 0, okay, when x is equal to 0, u is equal to 0, so you will have u equal to 0, and when x is equal to pi, okay, u will be equal to 3 pi. Alright, so now that we have changed our limits, okay, we can just evaluate these integrals straight away. So integral sine x is minus cos x, okay, so this is 3 by 4 minus cos x, okay, from 0 to pi. This means we will evaluate 3 by 4, so minus, I'll just shifting the minus out, okay, cos pi minus cos 0. So cos pi is minus 1, this is minus 1, cos 0 is 1, so minus 1 is minus 2, okay, you are left with 3 by 2, because then this minus and minus from minus 2 will cancel each other out. Okay, now let's see this one. So again, integral sine u du will be minus cos u, okay, from 0 to 3 pi, and you will have minus 1 by 12 outside. Alright, so you can again minus and minus cancel each other out, left with plus. So cos 3 pi minus cos 0 times 1 by 12. Alright, cos 3 pi is minus 1, cos 0 is 1, so again you have minus 2, okay, so you are left, so in this case, in this term, you will have 1 by 12 times 1 by 12 times, this now, 1 by 12 times minus 2, okay, you are left with minus 1 by 6, okay, so minus 1 by 6, and then you need to subtract 1 by 6 from this, because this is, yeah, these are two terms under addition. So you are left with this is 3 by 2 is 9 by 6, so 8 by 6 or 4 by 3. So that is how you evaluate your definite integrals. And if I have given you some function, okay, you can find the area of this function within these limits. Thanks for watching.